Just first off, I just want to say what an honor it is to be here. And I just want to thank Microsoft Education and also BBC Learning. We've had a great time collaborating with the BBC. And here, let me get logged in here really quick. And it has been just kind of a wild ride of lesson development over the course of the last 10 weeks. But we feel like we've developed some really fun lessons that I think kids are really going to resonate with students. So as Jennifer said, we have been working on developing lessons that kind of coincide with the BBC Oceans video. And the first lesson that we developed is related to sharks. And so to start off with, I have a few questions for you. Have you ever thought about where inventors get their ideas? Surprisingly, many new products were actually inspired by nature. For example, sharks have been credited with inspiring the design of the Mako Shark Corvette, antibacterial surfaces, and a drag-resistant coating that makes swimmers, sailboats, and airplanes move faster. Now, believe it or not, robots that mimic fish are actually being developed around the world as drones to go out and collect oceanic data and learn new things about the ocean. And so in this lesson plan, what we've done is we've put students in the authentic role of engineers learning about the science and the math behind fish movement, and then additionally developing a controlling system to maneuver a robotic drone fish in a virtual environment. So to start off with, we have students, I've got some props down here. We start off with having students make this 3D model that helps them understand how a robotic shark might move in the water. And so students are introduced with concepts related to flight. So over here on the z-axis, we have yaw. Over here on the y-axis, we have pitch. And then over here on the x-axis, we have roll. And these three positional movements, this three-axis rotational movements, are movements that enable an object to move around in three-dimensional space. So after students have gone through this analog component, they then move into a digital component. With all of our lessons that we develop, we like kids to have this hands-on, maker-based type project. As you can see right here, this is made from a wooden dowel, a spool, and some cardboard, and hot glued together, and then just some fun fish on there. But then we also like to get into some of the math behind it. And so over here we have this wonderful Excel worksheet that's been created by some of our data visualization experts that have serious experience with Excel. And we can start to look at some middle school standards-based math. So now we have some isometric transformations where we can look at a part of that shark and then start to visualize on the XY axis what happens to that fin as it encounters that pitch movement. So you can see what's happening with those points on that triangle, and students can start to look at what's happening in each of the four quadrants as that polygon starts to move on there. And then additionally, we've had just a great time with this last round of lessons as well, collaborating with some other groups in Microsoft Education, the Next team, and they have just developed some just beautiful resources for these lessons on PowerPoint. And so this PowerPoint right here is a great reference on how sharks move. And what we see is we have a little introduction here into the morphology of sharks and the different types of their fin types and the names of the fins. And so what students can then do is do a little research about the different fins on a shark and the movement that these fins help these sharks with. So we have the dorsal fin, we have the pectoral fins, and the caudal fin. And all of these help these sharks with this rotational movement. And then additionally, we also have some wonderful 3D models and visualizations. Now, PowerPoint has gotten even cooler. Now it does 3D learning, and we can have students go in and start to look at shark movement, pitch, yaw, and roll in 3 dimensions. I know, isn't that cool? And then, for the first time in any of our lessons that we've done so far, we've actually taken a little foray into Paint 3D. Here we go. Well, it looks like I'm going to talk about Paint 3D. So what students can actually do, and there's this wonderful, massive library of 3D models that are available to students, and they can take those models and they can bring them into Paint and then maneuver those around, manipulate them around, in a very CAD-like environment, and they can further reinforce their understanding of this three-dimensional movement. And so now that students have begun to look at the mathematics and the science and the movement behind shark movement and pitch, yaw, roll, they are going to be engaged in an authentic role of an engineer being challenged with the task of building a shark joystick. So I got another prop for you here. So in our lesson plans, all of our lessons, our goal is to democratize STEM education. So we're trying to, just do everything on the cheap. And so instead of having hundreds of dollars worth of robotics parts and these big box systems of STEM, we're trying to stick with the basics. And so as you can see right here, we've got this little shark drone that's kind of fun that the students build, and then out of a piece of cardboard. And then additionally, we have this joystick that is constructed of a square of cardboard, a wood dowel. We've got the shark connected with a washer and a magnet, and then copper tape that enable the shark to do these three different positional movements just by connecting the points on switches on this joystick. And then the students do some electronics work, and they wire up their joystick and send it into an Arduino microcontroller. And this is where things get super fun. So students now, as they build this, they have a testing environment. And so they can take this joystick and they can actually test the joystick and get live feedback from their joystick as a result of this connection to the Arduino. So this joystick, made out of basically stuff you pull out of the recycle bin, right, communicates with an Arduino, which then sends serial data into Excel, and then we have these wonderful visualizations that help students get some feedback on what they've built. So as you can see here, I've got some great yaw action going on here. And so now it looks like students can move to the left and to the right. They can control their drone in that direction. All right, let's do a little test on pitch. So you can see my 3D model there on the right. We can see that shark doing some great pitch action. And now let's try the roll. Oh yeah, there we go. So now, yeah. And obviously, this is not the case all the time. We've kind of greased the tracks here for the presentation. But students then, if their control system is not working, they then have to go through that iterative process of going back and checking each connection and determining what is going on with their joystick so that they can fix it and make it viable to work. And so the next component here is, now that we have tested the controller, now we need to actually look at a scenario where this shark is being controlled in an environment. And so before you take your, this robotic drone shark that you have spent thousands of dollars on, tens of thousands of dollars on, and just throw it into a marine environment and away you go, you want to test it in a virtual environment. And so we actually have, this is all Excel, folks, this is crazy. We actually have this virtual environment that students can now test their control system on. And so what I'm going to do here is I'm going to control, hopefully here, this shark with the joystick, and students are placed in this scenario where they are taking on the role of controlling this shark. So they may be going down in the Challenger deep submarine, deploy a drone, and then go out and try to find the nooks and crannies where the submarine couldn't get to and find some new life. And so now they're going to go on this biodiversity survey mission where they're going to go and collect data and see what types of species are out there. And then Excel will tabulate that down there below the virtual environment. So let's go ahead and start exploring. I'm going to start exploring and then do that. Try and get out of the way before I hit something. And so you can see we've got some great yaw going there. And then maneuvering up with pitch. And if you look down at the bottom, you can see those different species being calculated. A little roll action there. Oh, yeah, there you go. And hey, look at that, I just ran into an octopus. And so down there it says, hey, it looks like you stopped to examine the octopus after seeing 25 other marine creatures. That octopus looked pretty cool. I'm going to go check it out a little bit more here. And so now that students have had this experience of going in and doing this maker-based project and doing some, engaging in some science and engineering practices while building and testing this, then teachers can set them free. These resources are, a wonderful way to build these foundational skills and then engage your students in the engineering design process. And so now, depending on what you're doing in your classroom or what your needs are as a teacher, you could really engage your students in engineering design by having them take this joystick and redesign it so that it is more comfortable or more usable for a unique user, or they could be asked to redesign the joystick to repurpose it for a different function. And so, just a fun way to engage in STEM, but at the same time, it really allows a viability in terms of access because the materials are so inexpensive. I mean, this joystick right here itself costs less than $1. This Arduino microcontroller is reusable, and so instead of spending hundreds of dollars to design these things with each group of students in your classroom, you can just really do this on the cheap, and students have a really rich mechanical engineering experience with this as they build this electrical engineering, data science, and they also get some experience in computer science as well with the programming of the Arduino and making sure that's ready to go with their experimentation. So, just that's about all I got for you here today. But thank you very much.